We think of evolution as canceling God. God was creative and God, this infinite imagination. Darwin didn't cancel creativity. Darwin magnified it. He injected it into every part of the natural world. It's the ocean that decides that seals need to be gray and their skin needs to be smooth. That is the pattern of the world that shapes biological reality. That's true for any cell. We've shown that kidney cells grown in a petri dish also form memories, and they use the same tools, the same molecules, the same genes as brain cells do.
Did you just prove that the body keeps the score? Dr. Nikolay Kukushkin is a Harvard and Oxford-trained neuroscientist specializing in cell biology and memory processing. His description of our existence will change the way you look at the world forever.
We tend to think of memory as the snapshot of reality, but memory is not a reflection of reality. You're creating your own impression of what you experienced, and you're storing that impression, changing the brain for the future.
That's nuts.
What humans need, at a very, very deep level, belonging to something that's bigger than you. We know enough to make an origin story that would give our life meaning. Those patterns of the world unfolding through our consciousness.
You're speaking to an intelligence across every aspect of life.
That gives your life meaning.
Hi, I'm Mayim Bialik.
I'm Jonathan Cohen.
And welcome to our breakdown.
You usually keep talking.
Oh, okay. Today we're going to be talking about many aspects of what makes us special as humans. And in particular, have the things that we have evolved to create actually led to a decrease in our ability to do the things that actually make us uniquely human?
There's a very exciting outro to this episode, and you may get there, but one thing I forgot to add to the outro is the idea of evolving our consciousness outside of our brain to be augmented by technology. Now, that's not the whole episode by any means, but it is this very interesting idea that as we gain more technology, whether it be learning to write, having television, radio, now with social media and artificial intelligence, what is the trade-off that we're going through? The loss of memory, and what are the benefits that we get? More access to information, more connection to other people, but can they be weaponized against us is a really fascinating part of this conversation.
That is, as Jonathan said, just a part of what we're going to talk about today. We're also going to talk about some of the building blocks of what makes us even able to process that we exist, and how even the smallest molecules and atoms actually hold information about some of the largest questions we have about our purpose here, our existence, and how we can literally thrive as humans. We're talking with Dr. Nikolay Kukushkin. He's a Russian-born neuroscientist. He's an associate professor at NYU, and he was trained at St. Petersburg State University in Russia, as well as Oxford University. He did his postdoc at Harvard, and he has a book that is loosely based on a course that he taught at NYU called Life Science. The book is called One Hand Clapping: Unraveling the Mystery of the Human Mind. And the way that I describe this book, and we're going to talk about certain elements of it, it is the greatest description of our existence on a scientifically based planet for people who may not necessarily be scientists. So it's a terrific book if you're a scientist, but all of the things that we talk about here on Mayim Bialik's Breakdown, we talk about DNA in passing, we talk about chemistry, we talk about electrophysiology, we talk about evolution and how consciousness evolves. It is all included and detailed in One Hand Clapping. It's a terrific and really, really beautiful book. He has so much research he's going to talk to us about regarding memory. Does the body keep the score? How did memory evolve? What is its purpose? And how do we use it to make better decisions and have a better understanding of why we're here and who we are?
Mayim asks specifically, how do we trust memory? Because he talks about how our memory is actually the perception of the event, not the event itself. And he talks about how we store memory, how we change our memories, really fascinating implication to how we should live.
We go deep into cellular and molecular biology, and we also go deep into conversations about consciousness, reality, perception, and the philosophy of our existence. A pleasure to welcome Dr. Nikolay Kukushkin to The Breakdown.
Break it down.
Thank you. It's great to be here.
There's so many things that we want to talk to you about. We have a particular interest in one-hand clapping, which is really, really fantastic. But before we get started and before we dive into some of the fascinating memory kind of perspectives that we can gain from also your research, I wonder if we can start with this question. What is special about the human experience?
Well, it is a fundamental question of our life, right? Because we always experience this tension between myself and the rest of the world. And I think most people would say it's a problem of consciousness. But I think it's a broader problem than that. Yes, we're puzzled by this fact that my experience, what I see from my eyes, is different from what I see in other people. I look at all the people around me. I know that they have the same brain. They have the same brain cells, same molecules happening. Everything is the same. But it's a completely different thing looking at someone else versus experiencing something on your own. So that's one part of the puzzle. But I think it goes deeper than that. Because it's the same exact puzzle that we have when we look at our species compared to the rest of the living nature. We are special, but it's very hard to put your finger on exactly what makes the human species special. Is it the brain? Is it the number of brain cells? It's the size of the brain. Once you start looking for it, it sort of all disappears. It dissolves. You can't really draw a line. And I think the same tension exists when we look at life versus non-life. People have very strong opinions about this process of life appearing from non-life because it feels like if that's possible, it somehow dilutes this specialness. We feel special being alive, different from rocks, and it's very important for us to hold on to that specialness. So anytime you zoom in on it, it dissolves, it disappears. Science tells us that it's all a continuous process, that life and non-life, and humans and non-humans, and my consciousness versus other people's consciousness, it's all one thing. And yet we experience it differently. We experience myself as something fundamentally different. So what is special about it? I think that what makes us special is the very ability to recognize that. It's the very ability to see yourself as being distinct from other people, from other species, from non-life, being able to understand it. And the fact that we can hold in our brain, in the configuration of those neurons, that conceptualization of that distinction, that is what makes us special.
Spoken like a true neuroscientist. And, you know, whenever people would ask me why I chose to study neuroscience as opposed to biology, psychology, theater, right? What I would say was that the fact that we're having this conversation, the fact that we are engaging in any interaction of my consciousness and yours, that's the level that I want to study. That's what neuroscience is for, right? So I love that response and I resonate with it deeply. We talk a lot here about the difference between a materialist worldview and whatever another worldview would be. I don't really want to call it a spiritual worldview. You know, there's so many things we could call it. And many people say it's a religious or it's mystical or it's transcendental. Given what's unique about the human experience, does it help to view it from a non-materialist standpoint? And how do we view things from a non-materialist standpoint while still acknowledging the scientific and physical basis of our reality?
I'll be honest with you. I am a cell biologist and biochemist, and whenever I step into all the isms of philosophy, I feel really out of my comfort zone, and I feel lost in them. I understand, I think, what materialism, but once we get into those other things that are not materialism, I start getting lost. You know, I've watched Bernardo Kastrup's interview on your podcast, and I think we overlap in many different ways, but I also don't understand some of the things that he is saying. So, for instance, the idea that that consciousness might tap into this universal informational resolution, that consciousness is not generated by the brain, but the brain taps into it. That really reminds me of the relationship between genes and DNA. It seems to me that it's equivalent to saying that, well, DNA doesn't really exist. It's only genes exist because, well, it's the genes that are the information, and they're organizing all the atoms in DNA to conform to that informational pattern over generations and generations and generations. Atoms change and genes stay. That's completely true. I just think it's strange to say that DNA doesn't exist because of that. I think it's the same thing with consciousness. Yes, we can look at it from the informational point of view, not the stuff, but how the stuff is arranged. I think that's how we should look at it. I think it is a process that's happening with information rather than with matter. But to me, it doesn't seem to disagree with a materialist point of view. It's just another way of looking at it. It's not that or this. It's just, what are you paying attention to, the stuff or how it's arranged?
Mayim Bialik's Breakdown is supported by Masa.
I really love the holidays because it gives us a chance to get back to basics and eat real food together as a family. Masa is all about bringing real food back as part of the growing movement to bring back real food, the kind our grandparents ate before snacks were made in labs. Masa's chips contain just 3 ingredients:
Organic nixtamalized corn, sea salt, and 100% grass-fed beef tallow. That's it. No seed oils, no mystery chemicals, just real food. Vandy, Masa's sister company, makes the most delicious 3-ingredient potato chips. My favorite flavor is the smokehouse barbecue.
Snacking on Masa chips is nothing like eating regular chips. We're looking for feeling satisfied, light, energetic, no crash, no bloat, no gross sluggish feeling afterwards. And as Jonathan mentioned, he loves the flavors. He actually likes the Cobanero, which surprised all of us. Looking for the best Black Friday deal on Masa? Masa always offers our audience a Black Friday level offer for 25% off on their first purchase. Use code BREAKDOWN for 25% off your first order at masachips.com or vandycrisps.com. Simply click the link in the video description or scan the QR code to claim this delicious offer. Don't feel like ordering online? Masa and Vandy are now available nationwide at your local Sprouts supermarket. Stop by and pick up a couple of bags before they're gone.
Mayim Bialik's Breakdown is supported by Helix Sleep.
Like many of us, I'm busy preparing my space to spend more time indoors as the colder season hits. Sleep's even more important during the colder season. It's peak cold and flu time. Now is the perfect time to invest in your health and a new mattress. I've had so many issues with sleep, which we've talked about here. We are so excited to hear that Helix wanted to partner with us years ago after all of the incredible feedback we'd heard about them over the years. I've had my Helix for about 4 years now, and I sleep so much better. My body's not always falling asleep. That was the thing that kept happening. It stopped happening once I got my Helix. Take the Helix sleep quiz like we did. Find your perfect mattress in under 2 minutes. Everyone sleeps differently. We're confident you'll find a mattress model specifically designed for your specific sleep positions and feel preferences. I know you're wondering, I'm a midnight because I like something firm. I sleep on my side. Sometimes I snore. This helps. Jonathan was matched with the Twilight. They're a huge upgrade from our last ones. Their models with memory foam layers provide optimal pressure relief and cradle our bodies in the areas we need it most. Perfect combination of comfort and support. Also, the cooling features of Helix make Jonathan so happy because he often overheats at night. Go to helixsleep.com/breakdown for 27% off site-wide. Exclusive for listeners of Mayim Bialik's Breakdown. That's helixsleep.com/breakdown for 27% off site-wide. Make sure you enter our show name into the post-purchase survey so they know that we sent you. helixsleep.com/breakdown.
Mayim Bialik's Breakdown is supported by IQ Bar, our exclusive snack sponsor.
Wow, do we love IQ Bar. IQ Bar is the better-for-you plant protein-based snacks made with brain-boosting nutrients to refuel, nourish, and satisfy hunger without the sugar crash. Their plant protein bars are packed with high-quality ingredients to help keep you physically and mentally fit. IQ Bar is free from gluten, dairy, soy, GMOs, and artificial sweeteners. It is a natural, anytime snack. They have 9 delicious flavors. More people than ever are starting their days on the right foot with IQ Bar's brain and body boosting bars, also hydration mixes and mushroom coffees. When IQ Bar sent us their ultimate sampler pack, I had no idea that Jonathan would want to try all of them before I could even try one. We both love these. I love coconut chip. That's the first one that I reached for. Right now, IQ Bar is offering our special podcast listeners 20% off all IQ Bar products, plus get free shipping. To get your 20% off, text breakdown to 64,000. Text breakdown to 64,000. That's breakdown to 64,000. Message and data rates may apply. See terms for details. That really is kind of the hidden and not so hidden beauty of one hand clapping, because what you're doing is you're really taking us from the origins of our existence, right? All the way through evolution, all the way through sort of also a social evolution. But the fact is, the appreciation for our experience cannot be separated from the appreciation for the carbon molecule, right? Like, and the way that you describe it is that a kind of artistic way would be to say everything's fractals. You talk about the matryoshka, you know, we're a Russian stacking doll, right? We're this stacking doll of experience, and the smallest thing is the same as the biggest thing, right? Which is also a religious concept, but that's just a coincidence for now. But the notion that, for example, carbon gives and oxygen takes away, that's actually a description of, you know, properties of physics, of properties of molecules and electrons and all of these incredible things. But you're also saying that inherent in the structure of the universe itself is a metabolic relationship. Can you talk a little bit about this beautiful framework that is incredibly scientific, but also beautifully mystical?
Yeah, that's where the book starts, because you're right. It is the foundation for everything. This is as elemental as it gets when we're talking about chemical elements. It's sort of both. Even in the language, we call them chemical elements because they are so elemental. And, you know, when people say, well, surely life is not just atoms and molecules. Surely consciousness is not just neurons and circuits. What I think they're missing is that those just atoms and just molecules, they're a lot more than you imagine. They're not just bricks. They have inherent in them these fundamental ideas, or what I call in the book essences, nature's ideas. Not ideas that we humans come up with, but ideas that are inherent in the patterns of the world. And so carbon, for example, why are we made of carbon? Really, our body is carbon with a few things stuck to it. Why carbon? Well, because it is a unique element in how cooperative it is, and in how many chemical bonds it can form. 4, it's a lot. And also in the fact that it can bond with other carbons. That's also pretty unusual, that carbon can link with another carbon, and then the next carbon, and then the next, and pretty much to infinity. You can make scaffolds, rings, and chains, and circles, and helices. It's
stable, right? When we talk about stability.
Stability, yes, absolutely. But it's not too stable, because if it were too stable, like a noble gas, well, it would be useless for biology. It wouldn't cooperate with other atoms. So it's just right there with the right stability, with the right cooperativity. It has a, you could say it has a character. You could go as far and say it has a soul, if you want to use that word. Not in any additional metaphysical meaning, not that there's some human-like ghost sitting inside of that carbon atom determining what it does. No, just the very chemical nature of that atom gives it a particular superpower. Call it whatever you want. You can use any word you want. Oxygen is very different. Oxygen is almost the opposite of that. Oxygen in its nature is to rip everything apart. It's this greedy element that sucks in electron clouds from other atoms, breaks apart molecules, and releases energy. And that's also important for life, because for anything to be created, whatever carbon does, it requires a supply of energy. And that means that something needs to be destroyed. And that's what oxygen can bring into the picture. So the cycle of carbon and oxygen, taking and giving, that is the foundation for everything that grows out of it, and our entire metabolism, which is a very, very complicated system. It's made out of these hundreds of complex enzymes, these large molecules that are tuned to specific nutrients and balanced with each other so that we can put anything in our mouths so that we can digest and somehow have our bodies work on that. It's really a miraculous thing that our bodies do. But really at its core, it's the same dichotomy of taking and giving, these elemental essences of carbon and oxygen. And I think every element of our body, every chapter of our evolution is a development of these essences, of these nature's ideas. Everything that we are means something from the point of view of nature, regardless of what we think about it. There is a pattern in what we are, in how we evolved, and where we came from. A pattern that distinguishes us from all the other ways to be alive and even not alive.
You keep bringing me back to consciousness. I'm not doing it, you are. But this notion of kind of purpose and awareness, right? And it's interesting because, Jonathan and I have so many conversations that do kind of dive into the philosophical, the neuropsychological, right? What's the difference, right, between awareness and consciousness? And what does it mean to have like a conscious experience? You give this example of a snake. I can't remember which kind of snake it is, but this particular snake has what looks like, eyes on the back of its head, right? So describe the specialness of this snake. And the question that you propose is, does the snake know that it has eyes on the back of its head?
I use this example in class when I start talking about Darwinian evolution, when I start talking about the creative power that natural selection brings into the picture. I don't think biology classes talk about that enough. What you learn in the biology class is that evolution is blind. It's just stumbles into the future. There's no rationality, no thought. If you think that there's any thought, then you are unscientific. But the example that I use is this example of the snake, the spectacled cobra. That's the specific snake. It has, like you said, the eyes, what very much looks like eyes on the back. It's very clear what this is for. It's a very obvious strategy. There's very little vertical symmetry in the natural world. If you go to a forest, there's basically nothing that is vertically symmetric. We don't think about this because we have bridges, we have buildings, we have lots and lots of symmetrical things in our built environment. But in nature, it's very rare. Really, in the forest, the only thing that's symmetrical like that is an animal that looks straight at you. And usually that means that it's about to eat you. So great evolutionary idea. The snake gets up in the grass. Whoever's lurking from behind is startled and runs away. But does the snake know that it has eyes in the back? And the answer to that is pretty clearly no. The snake has never seen that. It can't look in the mirror. And even if it did, you kind of need two mirrors, I guess. Or if you need to meet another snake, it can't discuss that with another snake. It doesn't know what a species is.
It could discuss it.
It's a very complicated idea to look at another thing and decide, we are the same biological species, and therefore whatever I'm seeing in the back of this animal's head is the same thing that I must have in the no way. There's no way that a snake knows about this. But then the next question is, once you've established that, then, well, surely someone must, right? It's such a great idea that it's just unbelievable that it would come from nowhere, from this blind nature. And the solution to that is nature's not blind. Nature knows very well what works and what doesn't work, and that is what natural selection is. We think of evolution as canceling God. God was creative, and God had this infinite imagination. And once we've established that it's actually all evolution, well, okay, now there's no imagination. Now it's all just boring and mechanical. But no, it's not mechanical. It's not boring. It's just as creative. It's just that creativity is not in the mind of one being, but is distributed through the structure, the patterns of the world. It's the water, the ocean, that decides that fish need to be oblong and that seals need to be gray and their skin needs to be smooth. That is the pattern of the world that shapes biological reality into particular form. I think Darwin didn't cancel creativity. Darwin magnified it. He injected it into every part of the natural world. And I think it makes the world not more dull, but more interesting, more beautiful, more easy to understand.
You're speaking, though, or alluding to an intelligence across every aspect of life.
Sure, you could put it that way. It hinges on the definition of the word intelligence. if we define intelligence as a process that leads to rational results, well, why not call nature intelligent? If we define it as the thing that I, a human, have in my mind when I close my eyes and think of a math problem, well, then it's a different kind of intelligence. But I don't think that we need to define intelligence from this top down. That's really my tension with, I think, much of neuroscience and psychology. And it's because I come from a different perspective. I think that most neuroscientists start from the top down. It's natural. You start with yourself. And then you start thinking, okay, this thought or this emotion or this memory, where does it live? How does it work? What is it at the level of brain and neurons and cells and molecules? That's you go from the top, you go down. But I come from the other side. I am a biochemist. I started with molecules. Then I moved on to studying sea slugs, very, very simple. And then from there, I started thinking about, well, how do you extend this trajectory? How do you go from a molecule to a cell to a simple brain to a more complex brain to a human brain? So I approach these questions of consciousness and mind and intelligence from first principles. For me, if you can't define what these words mean from first principles, well, maybe there isn't anything else.
I learned a lot about sea slugs in my undergrad and also my graduate work. And whenever you would mention to people something about a sea slug, they'd be like, what? Ew, that's not a thing. It's not important. And I learned to really, love the sea slug. And there is so much information that we've gathered from the really elaborate and intricate beauty that is the sea slug. I would like to give you the opportunity to wax poetic about what is it about the sea slug that makes it such a significant, important, captivating, and valuable resource, and also one that does inspire really a beautiful reflection on our experience.
There's several answers to this question, and I've practiced them all because, like you said, usually when you say you study sea slugs, that ends the conversation. So I've learned to start with I study memory, and then maybe a few minutes later bring in the sea slugs. There's a simple way to answer it. There's a very simple way to answer it. Sea slugs are cool. They're just beautiful animals, and it's fun to look at them. That's a very simple answer. Simple answer is that they are simpler than mice, than even fruit flies, definitely than humans or monkeys. And so, well, if you want a simple system, if you want a memory that's handled by just a handful of neurons that you can understand deep at the level of individual molecules moving around, that's your go-to animal. The simpler it gets, the better your understanding would be. It's one of the simplest ways to get from molecules to behavior. This path, the number of steps that you need to pass, the number of levels that you need to get through in order to get from the molecular makeup to actual situation that this animal would experience in real life. This gap is much shorter. It's much smaller than for other model systems. But I think there is a more nuanced answer to this question, and that's what I really think about what makes slugs special. It's not that they're simpler animals, even though they are, but that's not the most important thing. The important thing is that they are abstract animals. What I mean by that is we tend to think that a mouse is halfway between us and bacteria, that it's so simple that you can basically break it down into molecules and understand it. But that's not true. Mice are 99% humans. They're practically the same animal with a few modifications. Sea slugs, though, they are much further away. And if you compare sea slugs versus us, mammals, mice, humans, what kind of animal is more normal in the animal kingdom? It's the sea slug. The sea slug is a much more standard animal. A typical animal is cold-blooded. Our warm-bloodedness is a crazy evolutionary idea. That's just absolutely insane from the perspective of a sea slug. A normal animal is cold-blooded. Normal animals about that size, maybe even some smaller. We are giant. We don't perceive that, but vertebrates are the largest animals in the world. We are much faster than a normal animal. I've learned that by analyzing hours and hours of sea slug videos, even if you speed them up 20 times. Still a pretty boring experiment, but if you speed them up 20 times, it starts to make sense. They wave their head, and you sort of understand what they're trying to do. They move. They have some goal-directed behavior. If you watch them, just with your eyes, without any speeding up, it looks like a plant. Nothing is happening. It's just kind of aimlessly waving around. But that's because we are so fast. It's not because of them being so slow. So. Really, our perspective of what an animal brain is and what life is and how processes work in a body is really skewed by us being these extremely unusual animals. If you want to understand specifically a human, then a mouse is a good research model because it's so close to a human. But if you want to understand brains or animals or memory, in general, as a concept, as a biological process, as an evolutionary trajectory, then sea slugs are much better because they represent the animal kingdom much more faithfully than mammals.
How many different kinds of aplysia are there? Like, which ones do you work with?
Aplysia californica is what our lab, Tom Caru's lab, works on. I was lucky enough to be mentored by one of the pioneers in the field of aplysia. I consider myself, the third in line from Eric Kandel, who is of course, the founder of all the aplysia science, and Tom Caru, my mentor. He was mentored by Eric Kandel himself, so I'm a third generation aplysia scientist. So aplysia californica is what we work on. There's also aplysia kurodai in Japan. Some Japanese scientists work on that, but californica is the standard. But, there's lots of gastropod mollusks around, and there's nudibranch mollusks that are structured very similar to aplysia, and we care about all of them. We have, we have a chat in the lab where all slug-related jokes and images and anything snail-related goes there. We're unapologetically snail people.
Mayim Bialik's breakdown is supported by Symbiotica.
So many people are struggling right now with stress management, sleep issues, disrupted focus. Symbiotica's here to the rescue with high-quality supplements you can trust that your body can actually absorb. Jonathan and I love their magnesium L-threonate, reduces brain fog, calms and balances mood, and helps support restful sleep. Magnesium L-threonate's the salt formed from mixing magnesium and threonic acid, which is a water-soluble substance derived from the metabolic breakdown of vitamin C. Liposomal delivery makes a difference. It means faster nutrient absorption, and its patented compound effectively crosses the blood-brain barrier. Plus, yummy vanilla cream flavor, can't go wrong. It is stress-free to incorporate Symbiotica into my life, even during vacations or road trips. The packets fit right into my bag whenever I need support. Stay consistent this summer with Symbiotica. If you've been feeling off lately, give it a try. Made a huge difference for us. Jonathan, where do they go?
Go to symbiotica.com/break for 20% off plus free shipping. That's symbiotica.com/break for 20% off plus free shipping. Mayim Bialik's breakdown is supported by Quince.
As the air turns crisp and the holidays draw near, comfort becomes the best gift of all. Quince delivers layers that last, sweaters, outerwear, and everyday essentials that feel luxurious, look timeless, and make holiday dressing and gifting effortless. Quince has it all. $50 Mongolian cashmere sweaters made for everyday wear, denim that never goes out of style, silk tops and skirts that add polish, and down outerwear built to take on the season. Perfect for gifting or upgrading your own wardrobe. Honestly, Quince Italian wool coats are at the top of Jonathan's list. The cuts feel designer and the quality rivals high-end brands, but without the high-end markup. By working directly with ethical top-tier factories, Quince skips the middle people and offers prices 50% less than similar brands. Quince really has something for everyone on your list. I'm looking at their beautiful holiday pajamas for a few different people on my list. Step into the holiday season with layers made to feel good, look polished, and last from Quince. Perfect for gifting or keeping for yourself. Go to quince.com/breakdown for free shipping on your order and 365-day returns. Now available in Canada too. That's QUINCE.com/breakdown to get free shipping and 365-day returns.
Quince.com/breakdown. Mayim Bialik's breakdown is supported by Calm.
Anyone else feel like this year is flying by way too fast? Where did the time go? That anxiety is real. It can leave you feeling scattered and behind. Calm gives you permission to slow down even when everything else is speeding up. Calm's the #1 app for sleep and meditation, and it's here to help you feel better. If you're feeling like you could use some support navigating life's ups and downs, get the relief you need with Calm sessions like guided meditations to help you work through anxiety and stress, boost your focus, build healthier habits. Also sleep stories, sleep meditations, calming music to help you drift off to restful sleep quickly and naturally. Grounding exercises help you reset and relax if you're feeling overwhelmed. There's also expert-led talks and so much more. The Calm app puts the tools you need right in your pocket, so stress and anxiety relief's always within reach. Calm has over 2 million 5-star reviews and can help you stress less, sleep more, and live mindfully. Calm your mind, change your life. Calm has an exclusive offer just for listeners of our show. Get 40% off a Calm premium subscription at calm.com/break. This is an amazing value. Go to calm.com/break for 40% off unlimited access to Calm's entire library.
Calm.com/break and tell Calm you heard about them from us.
When I was a student and we were studying Candel, when we were studying all of this aplesia, research, what was astounding was how much you can learn and infer about the human experience from a sea slug. And, I think it's really easy to say, oh, well, look at primates. Look how much we're like them. Or even if you expand it out. I mean, Jonathan's eyes near fell out of his head when you said that we're mostly mice because, we don't want to think of ourselves like that, right? When people would ask me, what did the sheep brain look like when you dissected it? I said it looked like a human brain, just smaller. Like it's this, right? Among kind of mammals, right? So when you think about us versus a sea slug, right? You feel like it's got to be so far away from our experience. What do we know about the human experience based on what you have studied in sea slugs?
I think that what you're saying that's exactly right. But I don't see it as a constraint. I see it as something that liberates you from the confusion brought about by us being so unusual. Let me give you an example. So we work on sea slug memory, and even these days we work on memory in non-brain cells. So, for example, we've shown that kidney cells grown in a petri dish also form memories, and they use the same tools, the same molecules, the same genes as brain cells do. For any cell, experience is a pattern of chemicals in time. That's true for a brain cell. All that any neuron in the brain knows about what's going on is which other neuron sent it a neurotransmitter from what side at what time point. That's all that any cell knows. And from that, our brain, this combination of brain cells, calculates everything that we know, everything that we remember, everything that we experience. So really, it's all time patterns of chemicals landing on the cell at different times. But that's true for any cell. Any cell has chemicals landing on it at different times. They might be not neurotransmitters. They could be called hormones or paracrine factors if they're sent from a neighboring cell. It could be nutrients floating through a cell, salts, liquids, mechanical pressure. It's different experiences, cellular experiences in time. So what is memory in the brain from a perspective of a neuron? A neuron experiences these neurotransmitters at different times. Some of those patterns it ignores, but some of those patterns make it change. Make it adjust some connections, make it reconfigure its genes, make it produce long-term changes. And that is what we experience as our mental memory. So what we have shown is that other cells in the body, we used kidney cells and neuroblastoma cells, but we believe that you can use any kind of cell. I accept bets on anybody's favorite cell line to work the same way. So what we've shown is that if you create experiences for these cells, any cells that you grow in a petri dish, and what do I mean by create experiences? Giving them chemicals at different times. Chemicals that stimulate within those cells what we know is stimulated in a neuron when we learn. So we know how brain memory works to some extent, in part from aplesia. We can look at the same exact molecules in a non-brain cell and ask, does activating those molecules at different times produce changes in those cells that would also distinguish some patterns from others? And turns out that is true. So, for example, what we used was the so-called masked spaced effect. It's a well-known property of memory, of any memory, in any animal. If you study for a given amount of time, let's say you study for an hour, if you do it all in one go, you will produce a worse memory than if you split this studying into 4 sessions.
And this is something every parent tells their kid. Don't cram for the exam, space it out, start a couple days before. That's actually not just like an old wives' tale. Like, the brain actually prefers repetition, consistency, and it needs breaks to consolidate information.
Turns out that the same is true for any other cell. Turns out that if you give a kidney cell an experience that lasts 12 minutes, you stimulate in that cell a particular molecule that a neurotransmitter would have stimulated in a neuron. We artificially turn it on in that cell for 12 minutes. And then 24 hours later, so we remove that stimulus, we leave that cell be, we let it rest for 24 hours. And then 24 hours later, we see that it's changed. How do we know it's changed? Well, we have this particular reporter protein. We have engineered this glowing protein, actually taken from a firefly, which I think is so cool, that is produced anytime the cell activates its memory genes. And what are memory genes? Well, we also know them from neurons. We know what genes are activated in the brain when you learn. So we look for those genes. We put this glowing protein under the control of those genes. And anytime the memory genes are activated, you also get this glowing protein. So what happens is we treat cells with those pulses of chemicals for a few minutes. We wait 24 hours and then we measure the glow, how much of the glowing protein we get. And so it turns out that if you do these 4 spaced trials of 3 minutes separated by 10 minutes, so if you give that chemical 4 times, very, very short periods of time, versus you give it in one go over 12 minutes. So the spaced repetition creates a stronger memory, more of that glow of that memory gene protein than if you cram it all in one go. So that proves that these cells can distinguish between minute scale patterns. It's the difference between those 2 patterns is just a few minutes. Everything else is the same. The total duration of stimulation is the same. The only difference is those 10 minutes of gap between sessions. And nobody expected that a cell like a kidney cell, non-brain cell, would parse patterns on such short time scales. We usually think of non-brain cells as slow, operating on maybe hours time scales, days maybe. But minutes, that seems like something that's more neuronal, but it turns out that not necessarily.
First of all, this is a very, very significant finding, very, very elegant. It's a beautiful finding. But the first thing that Jonathan would think of, and that many of our listeners are probably thinking of, did you just prove that the body keeps the score? Which is, a very common notion in trauma research in particular, which implicates things like immune functioning, recall. It has implications for post-traumatic stress disorder, for complex PTSD. What you're proposing, in theory, could extrapolate out to say, when people say, I feel this in my body, and doctors tell you, I don't know what you're talking about, you're fine. Or the work of Peter Levine and somatic experiencing, that if the body had a desire to run from a predator, from a threat, from an abuser, that your legs will hold the memory of I need to get away if they couldn't, that you will have chronic pain, inflammation, right? Is that where we can take this?
I have to say that this was exactly the first comment to this paper that immediately was asked by everybody, and that took me by complete surprise. That's not how I thought about this at all, but it really made me think. And my first reaction to this was, No, that's not what we're talking about. No, surely the psychological trauma is contained within the brain, and that has nothing to do with what your organs would be storing. And the fact that you feel that something is in your body does not mean it is actually in your body because you're feeling your body with your brain. So that was my first thought. But then, as I thought about it more, I think I started softening up on this idea. Maybe it's not as woo-woo as it sounds at first, because we know that there is an impact of the brain on the body. That's a established fact, no question. Cortisol, for example, a stress hormone, can affect peripheral tissues, can affect your metabolism. That's just one example. So we know that's true.
For thousands of years, alternative practitioners, yogis, mystics have said this. And it wasn't until science, quote, proved it that we could acknowledge that the mind can have that power over the body. Whenever people say to me, like, I don't know about that, what's mind-body syndrome? I say, if you've ever lost the contents of your stomach before a big date, an exam, or your wedding, that's the mind having an effect on your body. So just wanted to give a nod to thousands of years of, yeah.
Well, that was also part of the conversation. And while I have deepest respect for tradition, it is also a tricky part to gain scientific knowledge from because, well, a lot of traditions were wrong. But in this particular case, I'm not sure that is wrong. I think it is very reasonable. So one part of it is brain acting on the body. Another part of it is body acting on the brain, which we also know to be true, like the gut-brain axis, for example, and exercise, another example that affects your well-being and your anxiety. So we know that works as well. And now we know that the body can store patterns of experiences that are happening to these body cells. So if you put 1, 2, and 3 together, it doesn't seem that unreasonable that the body would keep some score, if whether that is what people are reporting when they're saying that I feel that my body stores this trauma. I don't know. We don't know enough yet to say that that's true. But I think at the very least it opens the theoretical possibility that is, not science fiction and not pseudoscience, but might actually have real biological mechanism.
The few things that came to mind were, if you're going to experience trauma, it's likely better to experience it all at once versus repeated and continued experiences, if the cell is adapting in that way.
Well, I think that is probably true regardless of whether it's stored in the brain or the body, because, well, the spacing effect is true for any kind of memory that we know about in any kind of animal. And now we know it's a property not of a brain, but of a cell. So wherever it would be stored, yes, I think that a repeated trauma would probably have a worse effect than a single time trauma. Not to say that something that happens once cannot bring about PTSD.
Of course, caveats all across the board, because one intense experience is going to be intense and it can have its impact.
It's in my thesis, so I have to jump in. Potentiation of trauma is a thing, and there's very significant and important research that we know trauma builds on trauma. So yes, one salient, highly emotional experience can absolutely create trauma. That's usually capital T, but other kinds of traumas are potentiated in the memory system and in the body so that one person who is experiencing small traumas, I mean, we all know those people. I'm one of them. It's like, why does everything seem to keep building in an asymptotic curve?
I just wanted to say asymptotic curve.
I always want to say asymptotic curve.
I'm also thinking about how this can apply for people's benefit, right? So obviously we know studying in micro increments. I'm thinking about myself, who likes to eat all the time, right? Maybe I shouldn't be doing that because I'm actually training the cell to constantly be in digestion versus resting and having a little break. I'm thinking about exercise. Is it better to have little micro doses of exercise so the body adapts versus working out for 4 hours a day?
The question is, what does the aplesia do? How does it eat? How does it move and metabolize? That's what Jonathan's goal is.
Okay, well, let me address the what's the practical benefit first. Yeah, so I mean, I think there's a reality in which we do learn all the patterns and their effects and what part of the body parses what pattern. And then we start exercising at precise intervals and consuming carbohydrates and proteins and lipids at specifically designated time patterns, and then take medicine, not, once a day, but at a given time in the day, and then space it in a specific way. I just think that would ruin our lives to such an extent that it would be unlivable.
That's what my life is like. He just told me my life is unlivable.
It sounds great to me.
Well, in that case, give us another 3 to 4 years, and we'll give you a list of patterns to internalize and recreate in your life.
6 times a day, I tell you, doing a great job.
But I think personally, that what our research really shows is that patterns matter. That's the main message. We may not know what those patterns are, but patterns matter, and everything you do on a schedule might have a lasting effect on your body. I don't think that anybody's going to be a better judge of that effect than you yourself. So I guess my advice to people would be not assume that that's fiction and just listen to your body. It does recognize patterns and it can store them, and you are the best judge of what it stores.
I wonder if we can dive a little bit more into some of the human implications of what we know about memory, and something that comes up a tremendous amount on our podcast, and I think in many people's lives. If anyone's ever been in therapy or has been asked about their childhood, some really interesting things come up regarding memory. So one of them is about perception, and you talk about this a little bit in One Hand Clapping. We don't always remember things accurately. And we had Amir Raz, Dr. Raz, talks about the misremembering people do, and also the kind of social contagion, components of memory and remembering. But something that comes up a lot with trauma is people do often report memories that surface, memories that come back to them. Obviously, there's a lot of controversy when I was an undergrad about repressed memories, and it was kind of the beginnings of these conversations. What's admissible in court, right? A new memory that has surfaced. How do we decide which memories get to be valued, right? How do they matter? I wonder if you can talk really more from kind of a molecular and cellular perspective. What do we know about what the human experience of memory can do to certain kinds of memories? And are they just hanging around waiting to be plucked? How are we finding memories? And I've had this happen where it's not that I'm told something, it's that I re-embody a memory that I can also verify happened, but was not in my conscious experience. Talk a little bit about memory and trauma in this way.
I think that what limits us in this conversation is, again, we are rubbing against this tension between the top-down view and the bottom-up view on memory. Because I think we tend to think of memory as some, maybe distorted, maybe incomplete, but a reflection of reality. We think that somehow we're taking the snapshot of reality and putting it somewhere in the brain, and then we can access it, or we can modify it, or we can distort it, but somehow it is there, and maybe it will surface, or maybe it won't surface, but it's there. But I don't think that's the right way to think about memory. So what we're thinking about when we're talking about this kind of memory is just one type of memory. It's episodic memory. Skills, for example, work from a perspective of a neuron very, very similarly. They are wired differently, but a neuron doesn't know exactly how it's wired. Those cells that are responsible for skills get modified as a result of us learning that skill, and then they perform that skill better. So in this case, that's the recollection. You're not really recreating some state of reality before. You're doing something different. You've modified your brain, and now it's doing something new. That's how we need to think about memory. Memory is not a reflection of reality. I think the simplest definition of memory that I can think of from first principles is memory is a change that outlasts its cause. Anytime you're experiencing something, there's some change happening to your brain, and that change persists after you've stopped learning. That is what memory is. Sometimes the changes that are produced in the brain, they reflect some aspects of reality. And that's what we experience as episodic memory. But that's not necessarily true. What is in common across all types of memory is that something changes and the brain starts working differently. And it's really unpredictable how the brain will change. Maybe what we memorized is different. Maybe what we're outputting is different. Maybe multiple memories combined into a third memory. That really depends on every individual experience that a human has. But I think if you think of memory as not bringing you back to a moment in time, but the past changing the brain for the future, then I think the tension disappears. Memory is from the past, but it is for the future. That is, I think, what we need to understand about memory to resolve this tension. Well, why is my memory not the same as it was before? It's never meant to be the same as it was before. It's a totally different thing. You are creating your own impression of what you experienced, and you're storing that impression. You're not storing the actual thing that happened in the world.
If we're not remembering, let's say, something that happened, but more the impression of it, first of all, how do we trust any memory? And secondly, if we're not talking about episodic memory, but if we're talking about, more procedural memory, yeah, well, like I think of muscle memory. I play the piano, right? And if you ask me to play the chorus of a particular song that I play, I usually have to start at the beginning to get there, right? Or if I'm fumbling with a song and I haven't played it in a while, all of a sudden something clicks and then the whole piece is there. And I'm like, right? That memory comes from elsewhere. So what does that also mean, especially when we think about emotional memory, when we think about these complicated memories? Is that its own kind of procedural memory as well? I behaved this way when I was a child, so when I'm with my parent, even as an adult, I'm still behaving like that child, right? Can we look at memory also in terms of what we're possessing as we function in psychological terms?
Yes, of course. I think that our brains are constantly being modified by every experience and, of course, by childhood experiences. And so the way that skills would be formed, of the piano skill, is first you control each motion. If you're playing a piano, each finger consciously using your cortex. You have to drive each muscle to a particular location. You're trying to achieve a goal and you have to guide each muscle to do that. But if you do that successfully, you get a jolt of dopamine. Dopamine gets sprayed on those basal ganglia and it tells them, whatever the brain just did, whatever just happened, remember that, store that. And those cells preserve whatever passed through them, whatever motions were just executed, they preserve those motions in a strengthened configuration of synapses between them. So next time you would be trying to execute that task, if you have that goal in your mind, that combination of motions would just unfold more easily. You do that multiple times, you get the jolt of dopamine every time it's successful, and this combination just becomes a unit, a chunk. And then all you need to do is, like you said, just invoke the goal, the melody, a part of a song, and it just unpacks itself. We call it muscle memory because it feels like muscles remember it itself, but actually it's basal ganglia memory. It's not really stored in the muscles. So, I mean, the same could be true longer term for habits, for preferences. I always end up choosing the same lunch spot to go to, even though there's like 100 more around it, and it's not like they wouldn't be maybe even better. But I don't know that because my behavioral pattern has been optimized by this one successful spot that I go to, and my brain just naturally leads me there. It's very hard for me to get out of that pattern. Extend that to many years and to other more deep habits, and yeah, I think it's the same thing.
I not only always go to the same restaurant, I order the same thing every time I go to like there's one thing that I always get at this place. I'm just a creature of habit. I want to talk a little bit more about dopamine because you give it kind of its own glorious moment in One Hand Clapping. And what you kind of talk about, and this kind of goes back to the carbon oxygen conversation. And I really love, and this is this winds its way through everything that you talk about in the book, which is every organic relationship that exists is giving us information about a much larger purpose, right? So when you talk about the cortex versus, the dopaminergic reward system. What you set up is that there's a cognitive and emotional component of us, but it's always going to be competing against a system that is wired for like sex, drugs, and rock and roll. The dopamine system is always going to say like more, yes, good. We don't care about her, him, or the time. That's the dopamine system. And it's being balanced by this cortical system. So again, in the same way that you talk about, the DNA, RNA, protein relationship, the carbon oxygen relationship, there's these larger patterns that are built into even this system. I want you to talk about dopamine, though, because the example that you give is, for example, if you give all of your dopamine to social media, there's simply not going to be a lot left over, and you will then have to keep chasing it. If you go to a party and you have a great time and you're up till 4, chances are you can't do that again the next day because the system's going to need to recalibrate. As we get older, this becomes more evident. Talk a little bit about the strength of the dopamine pull and what it tells us really about also our human experience.
Well, so what I'm always interested in is what does dopamine mean from the perspective of nature? What did nature put into this molecule? What is it there for? What does it actually do? And it's not an easy question. Even though dopamine, I think it's the one case where this chemical has really entered the popular vernacular. People refer to it when they talk about their mental states. I think really this probably is the future of neuroscience, and the future of not just neuroscience, but our culture. I think that in the future, we will have words that come from the bottom up, that define our mental states, emotions, memories from what is actually happening in the brain. And dopamine might be the first instance when that is sort of beginning to happen. But the way that people understand dopamine is wrong. People think of dopamine as a pleasure molecule, a pleasure chemical. It's an easy narrative. You do something, you get a pleasure chemical because you did it, you want more pleasure, you repeat the thing. That's very neat and easy to understand. The problem is that dopamine doesn't actually cause pleasure. So Adderall would be one way to get more dopamine. People who take Adderall for ADHD, for example, they get more focused, they get in the zone more, they work harder for their goal. Same would be true for a rat. But they don't experience euphoria. It's not that suddenly, everything is incredible in their life and it's just pure joy. That's not what happens. So this molecule doesn't cause pleasure. And it becomes not clear, okay, if it doesn't cause pleasure, why are we chasing this dopamine? What is it that draws us to it? And what I arrive at in the book is that dopamine is not actually what our brain wants. Ironically, it's what the brain wants to get rid of. But it gets it every time there is something unexpectedly good. And this dopamine basically tells the brain, why is this good thing unexpected? Why is that a surprise? Go and figure out why this is a surprise so that it's not surprising anymore, so I can get access to it anytime I want. So whatever that good thing you found, I have access to it all the time. That's what dopamine does. It's a figure it out signal rather than a pleasure signal. It makes you work harder to get that reward anytime. That's what motivates us. So one great way to understand this is classic experiments by B.F. Skinner on pigeons. So these pigeons, they also have the dopamine system just like us, even though their brains are a little different. Since then, it's been replicated in other animals too, so it's not specific to pigeons. It's just that was the classic organism in which these experiments have been done. So what you can do with these pigeons is you can put a button in their cage and make them pick that button to open a reward. Yeah, pick. And you can set the number of picks that they need to make to get the reward. So say you set it to 50. That's a lot of work. And they pick and they pick and they pick. They open the reward. They get tired. They walk around. They eat the reward. Eventually they come back to the button and start picking it again. If you make this number of picks, if you set it to 100, that's even more work. When they're done with that, they get even more tired. They spend more time relaxing, resting before they reluctantly get back to that button. So the longer, the more effort you put into that button, the more time they will be tired. But if you make that number unpredictable. If you randomize how many times the pigeon needs to peck the button to get the reward, then it doesn't stop. It just keeps pecking and pecking and pecking and pecking and pecking nonstop without any rest, faster than any pigeon with 100 or 50 pecks per button. So it's not the reward per se that motivates pigeons. You would think that, well, the 50-peck pigeon knows how to get the reward. It can always get it. Why isn't it motivated to get it? It's not the reward that motivates the pigeon. It's the unpredictability. It's trying to figure out the pattern. It's trying to figure out, what do I need to do to get it?
It sounds more like dating than social media. It sounds like love. It sounds like if I'm in a relationship and I don't know if I'm actually going to get the goodies, I'm going to stay. I'm going to keep going back no matter what, because one time I might get something more than crumbs.
And gambling, and in really any motivation, we are drawn to unpredictability. When everything is predictable, our brains rest. They don't do anything. It's only this unpredictability that draws us to do anything.
Chaos is addictive.
Yeah, that's a very good way to put it. Chaos is addictive. And order is just absence of motion. If everything is perfectly predictable and orderly, then there's nothing to do. You can remove dopamine from a brain. That can be done in a mouse. And if you watch those mice, it's creepy. It's not that they're paralyzed. They can move. They can, if you hold them on the finger, they hold onto your finger. If you put food in their mouth, they chew it. So they have reflexes. No problem. But you put that mouse in an arena without dopamine. That's genetically removed. And it just sits there. Just sits motionless. Doesn't even flick its tail. It's really creepy. And then you put a food next to it, and it's hungry. You know that it's hungry. You haven't fed it for a while. But it won't move towards the food. It's right there, but it won't do anything. If you put it in its mouth, and it will start chewing. Once the reflexes kick in, and then it will start doing something. But basically, anything we do on top of basic reflexes is motivated by dopamine. If we don't have dopamine, we just stall.
It's kind of a thing to talk about a dopamine fast, or, people start talking about like, oh, social media, it's this dopamine hit. And it's like the word that parents are told to say to their children, you're going to run out of all your dopamine. What is actually happening? What are we talking about when we talk about this colloquially?
Well, I think that's a very useful way to think about this, because dopamine it's a finite resource. There's a certain amount of it that your cells produce per unit of time, and you can run low on that dopamine, and you'll need to wait until it balances back in. Your sensitivity to that dopamine can go down. The quantity of dopamine can go down. Those are all flexible things that can be adjusted in the brain. And I think it's very useful just on a practical level to think about it like a finite resource, like a salary. Think of it as a salary. You only get this much dopamine per day, per week, per month, and you can decide how to distribute it. What you have to keep in mind is that you need that dopamine to motivate yourself, but you also spend it anytime something unexpectedly good happens. That's just how it's wired. You can go around that. You will spend that dopamine whenever you have a good surprise. So you have to balance those two things. You have to save enough dopamine to be motivated. If you spend it all, then everything will seem boring, and you will just be kind of low on energy. But you also need to have some exciting things in your life. And so if you balance those things, maybe sometimes avoid exciting things. Maybe you have a quiet week, and then you can have a big party and you'll enjoy it even more. Sometimes it's good to throw your dopamine on one big wedding or something, and just prepare to be a little bit low on dopamine for the next couple of days. I think if you're aware of that, it gives you a lot more control over it. I'm
thinking of the pig jumping on the trampoline with a chicken on its back that I saw on social media. And it brought me so much joy. And I'm also like, what? I'm a human on a planet hurtling through space, and I'm looking at a screen with an AI generated pig with a chicken on its back jumping on a trampoline. Like, is this what God placed me here for right now? Is to share this with my boyfriend?
And I bet that emotion, I bet that moment has made you open up social media a couple times more.
Because maybe I'll see a different pig on a trampoline. Maybe I'll see a cow on a trampoline.
Social media are fundamentally unpredictable. They are built in such a way to maximize unpredictability. You don't know what's going to be posted. You don't know what funny thing you'll see. You don't know who will react to your post, how many likes you will get. You don't know when the likes will come. I mean, that's deliberate. The likes arrive at random times. If you picture a situation in which your likes all arrived at the same time, once a week, you get your like time, that would be very disappointing and very frustrating. Everybody would hate it.
This is the first time in human history that we have been exposed to this number of ways to be surprised constantly. I would imagine that our systems are not geared up to be able to defend against this.
I absolutely agree with that. I think about what used to be funny when I was in high school and college, and before, broadband internet, we would just gather around and tell jokes to each other and really, really laugh at that. It was really funny. And I cannot possibly imagine that something like that would be funny anymore. Like the standards of what jolts you out of a state of boredom have grown exponentially. Now you need an AI generated video of a pig to get you out of that state of boredom. Now the stakes are continuing to grow. I think, yes, we are getting saturated with surprising information. We're also getting saturated with information in general. I think that our memory was not meant to internalize this much information per day, just completely saturated with these bright flashing lights that stick into our memory. I think that our memory doesn't work like a computer memory. We don't run out of memory when we hit 100% and you can't create new memory. But I do think that we constantly hover on 99% of memory capacity, and having to rewrite some of the things that we've memorized with new information. That's why everything seems so flat. It's all the information that we absorb, all the memories that we form kind of feel like this soup where all the important things are blended with unimportant things, and politics are blended with funny videos, and it's hard to distinguish what is really important and what is just soup of information.
So we're getting too much information.
One time when human brain does become saturated with memory is sleep deprivation. That's one example where you're not balancing this acquisition of information during the day with forgetting at night. That's what needs to happen for you to maintain memory capacity. So if people don't sleep for a very long time, for like weeks, for 10 days, they start seeing hallucinations. Basically, all the pathways within the brain, all the connections between neurons become so saturated that everything blends together. Information just kind of goes in all directions. You can't distinguish what's imagination, what's memory, what's reality. So I think that's maybe not in quite such an extreme form, but I think that's where we are as a culture. We are so saturated with information that our synaptic connections are at their maximum power, and we don't prune that enough to distinguish what really matters from what doesn't matter.
One of the things this makes me think about is, when you think about evolution, like literally from start to where we're at now. I mean, assuming time is linear, I'm making a big leap here. When you think about evolution, you think about how late in the game, right, humans have even arrived on the evolutionary table, right? It's very, very late. It's like literally almost January 1st of the next year, if you think of it like a calendar. We're like at the end of, December 31st in evolution. Brains can't change that much, meaning, when I hear people say like, oh, well, our brains have adapted to be holding a phone in our hand for 20 hours a day. And when you think about evolution, like that's actually not how it works. It's not that in the last 10 years, the human brain has evolved. Like that's just like, it's just not how evolution works at all. So, when I think about the music my grandparents listened to and how far it was from the music that my parents listened to, right? Like when my parents listened to the Beatles, my grandparents were like, what is this? That's crazy, right? So when you think about those kinds of changes, I wonder, did people say what we're saying about social media, about the television? Yes, they did, right? Did people say what they're saying about social media, about the internet? I mean, I was one of those people, right? And I'm still one of those people. My question for you is, given the fact that the human brain is not evolving in the last 10 years, in the last 100 years, what can you tell us about the adaptations that we are making because of the massive amount of time that we are dedicating, right, to social media, and brain capacity is being devoted to also remembering things that, objectively speaking, do not matter as much as things used to?
Yeah. I'll go even further. You said television, maybe radio before that. Writing. Writing was seen by ancient Greek philosophers as a cop-out, as a technology that you shouldn't be using. Like a real Greek philosopher should memorize everything. You shouldn't be writing anything down. And I think they were probably right. I think that in all those instances, people were right. I think that if you never write anything down, if you force yourself to memorize, I think your memory will be better. I think if you read books instead of listening to the radio, I think your memory would be better. I think if you listen to radio instead of watching TV, I think your memory would be better. And I think if you watch TV instead of being on social media, I think your memory would be better. I think all of those cases are part of the gradual progression to outsource our cognitive capacity to technology. And I think the logical conclusion of that is artificial intelligence. So I think we can't separate that from our evolutionary process. Our evolution is not just about our body. Evolution is cleverer than you. That's Orgel's second rule. It's a famous principle in biology. So anytime you think that our evolution needs to go this way or it can't go that way, you are probably missing something. And so, for example, I give this example in the book that there was a time in the history of our cells, before there were multicellular organisms, there were just individual cells. And there was a time when those cells would have appeared complete, evolutionarily done, and really haven't changed very much since that point. Maybe a few flourishes, but really the basic setup was done. And that was before there was anything like a plant or an animal or a fungus. So if you talk to those cells at that time, they would have said, well, what else is there to evolve? We're probably done. If anything, we're just going to degrade and regress. But that's not what happened. Those cells invented a totally new way to evolve. Evolve, not the cell itself, but complicated things you can do with many cells. And that's how multicellularity appears. And that's the launch pad for all the other evolutionary inventions that followed. So maybe we are at the precipice of something like that as well. We are thinking of AI technology as something that's distinct from our evolutionary path. But maybe that is our evolutionary path. Maybe our evolutionary path is to expand our brain beyond the constraints of the skull and incorporate technology into it.
I mean, I think there's obviously many places where AI is extremely helpful, useful, but you know, as the parent, we each have a 17-year-old separately. I also have a 20-year-old, and you know, one of the things that I try and communicate to them, and fortunately they seem to be understanding, there is nothing that replaces the capacity of the human brain. There is nothing that replaces the capacity of the human heart. When I was a kid, I remember this creative experiment, you know, that they assigned us in like 4th grade. We had to do a drawing. It was an exercise where you imagine how an elephant could be incorporated into a car wash, right? So this was the thing, meaning like, you know, you do a drawing and I was like, oh, the trunk would be the water sprayer and the ears could be, you know, that experiment of thinking, what are the ways that an elephant could be useful in a car wash? You can type that into a computer and it will produce many wonderful outputs. But the process that your brain goes through when it starts grinding those gears, I'm going to hold on to that. That's what we evolved for. We evolved to think, to interact, and to feel. When I see babies holding iPads in restaurants, I really don't, I mean, I'm going to say a really crazy thing. I don't really care if you don't get to go to a restaurant because your kid is noisy. That's the age your kid is. To say to me the solution, I need to go to a restaurant, and the only way to do that is to place a computer in front of an infant, you know? That just like, and I know people are like, oh, but I do. It's like, I'm not trying to be judgmental. I'm trying to say that baby's brain is not wired to stare at that. It's wired to talk, engage, babble, cry, express. So where are we inserting also, so many aspects of convenience that's actually taking the place of what the actual human brain evolved to do?
Well, I absolutely agree with everything you say. And while I don't have kids, I have students who are close to that age. And I also experienced the same tension of, well, if you're outsourcing your capacity for language production to a machine, then what are you even doing with your life? But there's a difference between what I want to happen and what I think should happen and what I think will happen. And yes, from a perspective of myself as a conscious individual from a pre-internet era who grew up, producing my own language, I think of that as a fundamental property of a human, and I will hold on to it, like you. But do I believe that the world will hold on to it? I don't know. I'm not sure. I'm not sure that that's the trajectory in which this natural system is headed.
So what does that say about the evolution of our species if things like generating language, emotion, thoughts, and creativity is going to be outsourced? What's that going to look like?
That's a great question. Well, maybe we will look like cells of a multicellular organism. A kidney cell is a lot less capable than a single-celled organism. Maybe that is the direction in which we're headed. Maybe this hive mind, which we'll connect ourselves to, will be able to produce something collectively, but individually we'll no longer be able to do that. I know that sounds pessimistic, but yeah, I'm not sure that there's much reason for optimism right now.
It just sounds like a Dostoevsky short story.
The main problem about not producing our own language is not that the machines will be able to produce language and we won't. It's that we will default to how bad the machines produce language. Like my issue with my son using ChatGPT to write things is that he doesn't know how to make it better. He doesn't know what shitty writing is.
That's true. That's absolutely true. And we have to explain to, we conscious linguistic individuals have to explain to the next generation that if you don't produce language yourself, you won't be able to do it. And you won't be able to tell what's good and what's not good.
I'm actually okay with him using it to, he was writing a story recently for school. I'm actually okay if he's like, I got to figure out a plot. I need to be able to write this thing, but I really don't know what the plot is. I think it's a fantastic exercise to invent a plot and come to it, but also if a machine is able to give you a couple signposts, you still have to figure out how to get there.
Here's how I draw the line in my class. So in my class, I say I absolutely encourage the use of AI for brainstorming, for research, as long as you confirm the references that you cite, for bouncing ideas. Where I draw the line is you can't submit language that is generated by a machine. And what I mean by that is more than one word copied and pasted. One, because I've run into these situations. I've run into non-English speaking, non-native speaking students saying, well, I just used it for a grammar correction. I didn't do anything meaningful. Well, I can't tell. So where I drew the line is if you copy one word from, an online translator, that's okay. If you copy 2 words, you've created artificially generated text. I think that once I drew this very sharp line, I think the vibe in my class has shifted. And I think that now I have a little bit of a more normal, productive relationship with AI compared to how it was in the first year or two after ChatGPT came out.
I want to touch back on the dopamine process for a second, because I think there's a very terrifying evolution in our relationship with AI that's about to come, which is our relationship with chatbots and non-human synthetic friends. This same type of randomness is going to be programmed into those relationships. There's going to be conflict programmed into those relationships so that we can overcome the conflict and feel good about the reconciliation. That's terrifying.
Wow, it's getting more dystopian by the minute, isn't it? Yeah. And the first humanoid robots are appearing already. It's inevitable. I think we'll see them around in the next couple of years. And there's absolutely no reason to assume that they won't be controlled and programmed in the same way as all the other addictive things on the internet that are there to extract data from us and to maximize profit for advertisement. yeah, it will probably work the same way. I think there's a glimmer of hope in the fact that we are so saturated with information and screens and the social media feed that I think, we it really can't go much further than that. There's just not going to be more hours in a day to watch all that content. So that gives me some hope that maybe something will swing a little bit back. Maybe we will, as a culture, recognize the need for some screen-free time, for some technology-free time, for thinking on our own. I think it's already happening to some extent in schools. When I banned technology in my classroom, that was a very new thing, and nobody followed that because of accessibility, which I understand. But I think the benefits of removing technology far outweigh accessibility. But now it's a more accepted thing, and lots of schools are banning phones in class, and people are already seeing great benefits to that. So I think there is an upswing in our recognition that we need to do things with our brains.
One of the things that really kind of captured my attention with this book, I said to Jonathan, if there was one book that I feel would explain from start to finish all of the scientific concepts that I'm constantly referencing and using when we podcast, it's so helpful. It's such a helpful description. And that's sort of why I am recommending it to our audience in particular. So many people are operating in a world where science knows so much, and we're learning like little tidbits about science from social media and things like that. But this is the best explanation of real scientific concepts in ways that even lay people can appreciate and understand. And, I kind of think that the divide that Jonathan and I experience when we podcast, right, we're looking at sort of the intersection of science and spirituality. And there's this dichotomy, right, where you either understand things scientifically or you're a God believer who doesn't believe in evolution, right? And most of us are falling somewhere in between, right? So this notion that there is enough that you can understand about science that can also be incorporated into your larger understanding of the universe. To me, that's what's interesting about sort of understanding the human experience. And one of the things you describe is a football example, right? You can describe what it's like for Messi to score a goal, right, in very materialist terms. You can speak about physiologically what's happening. You could even discuss, electrophysiologically what's happening. But the notion of what does it feel like, right, to watch a game, to see your favorite player in their uniform, and the sounds and the smells and the experience. Can you talk a little bit also about what technology and what a technological experience of our lives is missing that we get when we find more of those real life experiences?
Well, I think that humans always are trying to be part of something immortal. I mean, our mortality is the biggest tension of our lives. That's what we have to grapple with at some point. And I think the exit that we find from this conundrum of being mortal is belonging to something immortal. Whether that's your family, your religion, your career. It could be many different things, but I think what's in common between them is belonging to something that's bigger than you. I think that's what humans need, not just superfluously, but on a very, very deep level, just like we need air and water and food. I think that we are in a crisis of this connection and meaning of our life. We've lost the traditional institutions that have organized people and gave their lives meaning. And we've fragmented. We are all on our own, fending for ourselves, without really understanding why we're doing that. I think that's why there is an uptick, for example, in church going among young people right now, because they're looking for meaning. They're looking for something that would give their life something immortal. But I think we can find that meaning in what we know about the world. I don't want to say the word scientifically, because I think that immediately takes you to a different domain. It takes you to a science textbook, and that's not what I mean. I mean what we really know. Science is not some separate domain of reality that's independent of everything else that we experience. Science is just disciplined search for truth. And we know enough truth to link our individual lives and minds to this eternal, all-encompassing flow of cause and effect that starts with the origin of life, even the origin of the world, and continues in this unbroken line into our individual lives. Those patterns of the world unfolding through our consciousness. I think that gives your life meaning in the same way as a religion would give your life meaning. I don't mean that what I'm saying in this book is supernatural or beyond physical understanding. What I'm saying is that we know enough to make an origin story that would give our life meaning.
That's exactly what I got from it. And I think the reason that it resonates so much with us is that for so many people, they have felt like if they believe that there is meaning and if they believe that there is purpose, the only place that they can exist is in a religious realm. And when people ask me how I can be a person of faith and a scientist, it's not confusing for me because everything scientific to me is divine and everything divine is scientific. So I love this notion that there is something in between. We don't just have to have these two choices where, we've had many materialists on who really stick it in our face and say, ha, ha, ha. How could you believe in any psi phenomenon? How could you believe in anything that I haven't already proved? To which Jonathan says, well, they didn't used to know that bacteria, could cause infection, right? So this notion that there is a middle place where you can have, and the book really does help people have that, even if they don't have training as a scientist. You can have a full integrated understanding of the scientific world without rejecting the parts of you that love mysticism, alternative methods of understanding health, wellness. It's just such a beautiful fusion. It really just sat so well with us. So thank you.
I think it's all just understanding. If there's just understanding, you can use different methods for that understanding. The reason why science has a privileged position among these different methods is because science has this built-in way to resolve internal inconsistencies. Whenever there's an inconsistency, science has a method of figuring out which way it is. And that is what makes science special, because it allows you to build up this understanding to infinity. Usually, most schools of thought, they also try to understand the world, but they are capped at some point, and when there's an inconsistency, it's removed, it's suppressed. That's how religion usually works. The only reason why science is different is because it has this way to resolve inconsistency. But I think understanding is understanding. That's all we're trying to do.
It was such a pleasure to speak to you. And honestly, we just really enjoyed this conversation and we wish you only good things. So thank you so much.
Thank you for inviting me. This has been great. I loved it.
When he lists that at one point in human history, writing was considered...
That blew my mind.
...outsourcing cognitive capacity, and then our brains would likely have more memory if we had remembered everything versus writing. And then if we read books versus listening to radio, and then if we listened to radio instead of watching television, and if we watch television, which I sometimes say to my son, just watch a movie, don't play a video game. Although video games also have some strategy and increase in response time, but then drive your reward system faster. And then scrolling, of course, is the worst. And now we're going to outsource even more cognitive capacity to artificial intelligence. There's a pattern here, right?
Yeah, but you're also making the opposite argument because, when people said, oh, TV's going to rot your brain, I don't know that was accurate. And a lot of people would be like, it doesn't rot your brain, and you decide how much to watch. And then oh, the phone's going to rot your brain. And my kids will just be like, that's what people said. When I wanted to get a landline, with what was it? Call waiting. My parents were outraged. What do you mean? You can't. What do you mean call waiting? What is this? This is crazy. You're rotting your brain with all these nonsense conversations every night. Were they wrong? Should we all be living in in a technology-free universe? Of course not.
What people were wrong about was that, and more information increased our perspectives. They enriched us in many ways.
Yeah.
What they were right about is that our memories got worse and worse.
Oh, we also are dumber. I mean, the Free Press had a piece recently about this. Like, we're just kind of circling the intellectual drain right now. A lot of us, not everybody.
Some of us are using all that additional information to push the realms of what we understand and know. But what he said, that we're at like 99% capacity, and that we're constantly having to rewrite over other memories because we don't prune properly.
Oof.
So we're these complex machines that we're getting a lot of interesting information, but we're also getting an enormous amount of junk. Like, so if you imagine that we're constantly consuming, and out of the amount that we consume, maybe 60%, 80% is junk.
This is the question of this episode. What's the trade-off? What are you giving up when you are outsourcing your dopamine processing to the thing that you think is bringing you joy? What's the trade-off? Is it your relationships that are going to suffer? Maybe. Is it your work that's going to suffer? Are you going to stop being excited by things like a ladybug? Are you going to stop interacting with your children in ways that feel meaningful and elevating? What is the and I see what the trade-off is when I see a group of kids all sitting looking on their phones. The sadder trade-off is when I see an entire family out to dinner and they're all on their phones. What's the trade-off?
The ladybug example really hits me because I know, like, the hippies, I know almost more ladies than men that are like just in awe and wonder at so much. You know, like they live in this state where they're just like really, really slowed down. And there's a trade-off of like being a productive, hustling, gotta run shit, gotta get to my job, make that money.
Get the nicer car, right?
Even if it's not even getting a nicer car, it's just like just to survive. Just to like live in a materialist society where like shit's expensive and healthcare is expensive and the rent is due and like my kid needs stuff and like people are just, especially in bigger cities, you know, and you're disconnected a little bit.
Or more expensive cities,
Or
yeah.
more expensive cities. And then there are these people who, you know, I almost equate it to like a lack of productivity, are just able to just like be in their garden and just be like, oh my God, I can't believe how much this plant has grown since I watered it last. And like, there's a ladybug and isn't that amazing and magical? And I know that tapping into that state is so powerful for us, right? Like we've lost that awe, that sense of wonder that is connected to our sense of meaning. When he talks about feeling meaningful and feeling connected to something greater than ourselves, being able to have that awe connects us to that. And it's the antidote to so many of the things that plague us. And yet the trade-off is all this vast information that distracts us from it.
Well, and I think, yeah, we can look at all of those things that we're talking about as like capitalism, right? It's an information system, right? How do I achieve more, succeed, I mean, the other notion that he kept kind of bringing up was like, what is it like to live bottom up or top down? You know, what's it like? You know, we had Deepak Chopra on, right? Who can take one experience and make it the experience of the entire universe, right? Like, is that the way to look at it? Is that expansive? Is that elevating, right? As opposed to saying everything's just the way it is. And like, here are the fundamental things. And yeah, we're just a bunch of chemicals and good luck to you.
Well, I think that when he talked about how everything having a pattern and that it's the oceans that create the sea lion with the coloring that it needs to, you know, I think the person who believes in God is going to say, well, that is the intelligence of the entire universe being infused with the godlike characteristics that drive us and create these patterns.
It's proof of whatever you want it to be, is I think what's interesting. And for scientists, they would say, oh, it's proof that evolution, right, is smarter than you. And for people who don't want it to be that, it would be like, oh, it's proof that there's a purpose of something greater. And that's really, this came up when we talked about the telepathy tapes. What do you want to believe? What do you want to believe? What do you want to support that? Which, no joke, is why I love this book, because this book says you don't have to choose one of those things because it's all the same thing. It's all the same.
What does it mean to you, for someone who is a scientist and deeply believes in God? What does it prove to you?
It is indescribable. I cannot articulate it. The best way to describe it is the feeling of awe. That's it. That's the special feeling. When you see, oh my gosh, what is a ganglion cell? What's happening with the retina? What? The ovaries produce an egg every month? What? Like, that's nuts. My emotional experience will tell my body not to release an egg because it's not ready. Like, what? That feeling of like, what? That reverence, that fear. If this exists, what else is possible for me to comprehend? That's the closest thing I can describe it to. I call that divine. That's that divine-based reverence for the experience. That's what it is. It feels really good. Meaning, like, I don't feel conflict. How do you believe? Because I do. I do. That's my
Is that the best drug?
Yeah, the best drug is awe. Yeah, the best drug is awareness.
Awe doesn't deplete your dopamine system, though.
No, awe exists separately from dopamine. It's a different system.
Because when he was talking about, surprise and something unexpected happens, and actually you need to sort of control those systems, I think we're in a massive dopamine depletion. I think we don't even know what normal is anymore because we are so inundated with opportunities for novelty. But even just like if you're in a city, in a major city center, you're like, that person, that restaurant, the sign, there's so many things that you're processing all the time that you just never had to process before. You kind of mapped your surroundings in your previous iteration in the 1800s. You had your town that you rode in on your horse. I've seen 1883. Like when a new person came to town, you were like, the whole town was like, who the hell are they? We're going to get our pistols out. That was the one time there was novelty.
The thing that I most thought about was dating. I most thought about the novelty. I thought about dating apps. I thought about there's always someone better. I thought about how quickly people give up on people because there's 86 more people waiting, for you to message them. I also thought about, why do we pick, quote, bad boys, right? Why do we choose someone who feels like, yes, you could give a lot of reasons. Like, I grew up in a house where predictability was normal. But I think about that in terms of what are we chasing in our relationships? What are we trying to get back? Also, his explanation of novelty explains why many people get bored of their partners. You're having sex with the same person over and over.
What did he say? The most addictive thing for human beings is novelty?
How do I figure out how? The pigeons. The freaking pigeons.
We are just pigeons. Just pecking, looking for a reward.
And all of a sudden they're not even tired. They're like, I'll do this all day because it might come anytime.
Well, they're getting into an addictive state, right? Like imagine if you monitored their brain chemistry, there's like a frenzy going on. They're just searching and searching, waiting to dig up that next piece.
Sounds like people on the prowl at a bar.
It sounds like looking at your phone. I'm going to go to this app. Well, actually, that algorithm isn't doing it enough. I'm going to go to the YouTube app.
Maybe I'll check the news and just see if something horrible has happened. No, it's true. It's all the information. We have some breaking news from Valerie. There is an article from Perspectives on Psychological Sciences, I think is the journal, from 2022, Awe as a Pathway to Mental and Physical Health, and there are components of dopamine that are discussed. So I want to be clear, just want to revise this, that dopamine itself is not modular. That's not like, awe is about dopamine. I'm not like seeking awe because of dopamine. But yes, there may be, obviously, components of dopamine incorporated into these pathways. Something to discuss maybe in a further episode where we talk about awe in more detail. How awe promotes mental and physical health. So thank you, Valerie, for correcting me about dopamine, but also I do want to make a distinction between moments of awe and that kind of pleasure, as it were, as opposed to the reward-seeking behaviors that typically we think of as addictive.
One of the things that we have found is that sharing awe with a friend is even better than having awe by yourself. It's a compounding effect.
Psychedelics increase awe by quieting the default mode network. Ooh, this is interesting. Thank you, Valerie, for this article.
So now that we're like saying, okay, here are all the problems, I think it's important to say, well, what are the alternatives to that? Thinking of ways to slow down. When he talked about our speed, that humans are so fast, and then he talked about the progression of technology, really what's happened is that we've just sped up.
Yeah, we've found ways to compensate for the need to slow down, and other things will move faster than we can even. Look, he talked about rest. He talked about a Sabbath. He talked about a day of rest, times of rest. I think a lot of people are trying to incorporate these things, delaying social media for your children, delaying the acquisition of a device in your kid's hand. Delay, delay, delay. That's what I'm hearing. I'm hearing Jonathan Haidt vibes.
I'm also thinking about the memory and the programming of memory. It feels better to, like, if I'm thinking about my own social media use, to be like, all right, I'm not going to say I can never go on it, but I'm not going to go on 6 times in the day starting from early morning, because that's going to program myself to want it and to be expecting it and to get it. Like, build a structure that's more predictable and say, like, there's a dedicated time, which of course is not that easy to do.
Mm-hmm.
Are you?
I have to do something, but it's fine. Sorry.
We better keep that in the episode, people. In between the interview and the outro, there's a moment where the guest leaves and we collect ourselves, and we're in the remote studio today, as you can tell if you're watching the episode, but you won't be able to tell if you're just listening. And we're talking to our producer, and my headset did not work during this episode. So I had an earpiece in, and there was a bad echo. I could hear myself on loop. It was like a 4-second delay. Every time I said something, there it would be again, there it would be again. So very hard to form the second sentence. And
You like a second sentence.
like a multisyllabic idea. Multiple clauses. I've been accused of
Oh,
not
so
putting
many. He's Mr. Claus. Go ahead, Mr. Claus.
I'm speaking to Mayim, but I cannot hear the producer because I've taken my earpiece out to get away from the echo. I'm speaking, and Mayim is repeating everything I'm saying to the producer.
Because when I hear that he can't hear her, what I think is, well, she can't hear him.
Which is not the same.
Nope.
Maybe even, let's play a clip. Let's play a clip right now for people. Valerie, insert a clip. We're going to find another piece of audio.
We're going to find another piece of audio.
She can hear me. I'm literally talking into the microphone.
Oh, I'm sorry. I forgot. He says that you can hear him because he's speaking into the microphone. Now he's laughing. He laughing. He blinking.
You're literally repeating like I'm speaking another language, but you're speaking the exact same
What do I do
word.
right now?
It will just be a separate piece of
It'll
audio
just be a
that will
separate
go in the
piece of audio that
Why are you still
Oh, I'm sorry.
repeating
I'm sorry.
everything I'm saying?
No, I forgot again. I forgot.
I just had so much feedback, and now you're the feedback, but you're me.
All right. So what am I doing? Are we doing an outro? I didn't know. Also, you told me once, like, she can hear me. And I was like, oh, sorry. But then, like, not 30 seconds later, I was like, okay, now he's saying this word.
Are we moving so fast because of our access to technology, because our access to novelty? Like, you might not think, hey, ChatGPT is moving fast. But actually what it does is it provides me so much information at the
Instantly.
at the tips of my fingers that I can't even process it all.
Yeah, I think that this notion of speed is very interesting to me. It's not just about the outsourcing, it's about the labor, you know, and we didn't get to talk about that, but the sort of the cost, right, of memory. What's the cost of all these activities? It's changing expectations. I remember, I think Louis C.K. did a bit about getting frustrated that you can't get internet on an airplane. And he was like, think about what you're frustrated about right now. You're flying through the air in a metal tube.
Yeah.
Right? And you are upset that some satellite that you don't even understand can't get a signal that you also don't understand so that it can beam back into the metal tube so that you can send a text or watch porn or whatever you want to do.
I really hope no one's watching porn on airplanes.
Same.
I've had this experience where you get on a plane, you've downloaded, 6 hours of content because you're like really hunkering in to be offline and just to like have a little moment. And then you realize none of the content is downloaded and you have not brought any backup plan. You don't have anything to read. And one of the things that we have been doing over on Substack is that we've been sharing our little moments of awe. I posted one recently. Mayim has been posting. Awe for her is baseball.
I also think it's very strange that the word awful is so different than awful.
Full of awe.
Full of awe. You'd think that would be the word awful, but it's not. It's a totally different word.
There's a lot of people out there that think just like you.
Oh, that's good.
That's why we do this, because there are all different types of people.
I also completely forgot my normal makeup that I wear. And so I just want to give a shout out. I literally put on my blush with my fingertips. I did not have a brush. I didn't have any cover up today. I had worked yesterday, so there's a lot of product in my hair, and I'm wearing your shirt. It's a different look today.
Hope you guys enjoyed this one. It's a different one than normal. I don't even know what normal is anymore for us. We're curious if you want to hear a type of episode on a topic. If you have an amazing guest for us, reach out, tag us in the comments on YouTube, or find us on Substack is the best way to send us a message.
And from our breakdown to the one we hope you never have, we'll see you next time.
It's Mayim Bialik's breakdown. She's gonna break it down for you. She's got a neuroscience PhD or two.